So in question 3, we're given this container, which is used to take garbage away from construction sites. And this is on the back of a truck. It's not super important here, but we have this model of it. It can be modeled with a cross section and with a trapezoid. So this shaded area is what we are going to be interested in. As we want to, in part A, we want to calculate the volume of this container with different conditions. So if firstly we can see that the cross section is constant, so if we look at the shaded gray area, so the front of this trapezoid of this container, then this is constant throughout. So if we can find the area of this, then we can simply multiply it by the length of it into the page, and that will give us the volume of this container. So in part 1, we are told that the top is 11 meters. So if I were to sketch it down here, this is what the front of the container looks like. We are told this is 11. We know this is 4. We know this is 10. And we know, well, this is all we know. And so we also know that this is 1. We can calculate that. It has to be 1 because this side here is 10, so the remaining has to be 1. So we just need to find the area of this trapezoid. For that, we will need the height of the trapezoid. So let's call this height h. So the height we can calculate with Pythagoras is simply the square root of 4 squared minus 1 squared. This will be like 3.87 if we plug it in our calculator. And then the area of the trapezoid will simply be, we can already write the volume. So the area of a trapezoid firstly is going to be 1/2 times the sum of the two long sides, so 11 plus 10, base and the top. And then we multiply this by the height of the trapezoid, so 3.87. And then, as I said at the beginning, we multiply this with this 3, as it's 3 units into the page. So this will give us the volume to be 122 meters cubed. And then in part 2, we're given a different variable. So now we're told the height of the container to be 3.2 meters. So what we could do is draw the same diagram. It's just that we have a new known variable. So this is still 10. This is still 4. Now we know the height is 3.2. We know this is 10 as well. So ideally what we want is this distance over here, as then we again have all the information we need. And again, we can use Pythagoras to find this distance x, simply the square root of 4 squared minus 3.2 squared. This will be 2.4. So with the same method, the volume is again 1/2 times, well, now the long side is 10 plus x, so 12.4 plus 10 multiplied with the height, 3.2, and again multiplied by 3 to find the total volume. This will give us 108 meters cubed. And in the last part, we're given the angle, theta. So let's draw it again. We have this. Now we know that this angle here is pi over 3. This is still 10. This is still 4. And well, now we don't really know the height or the, so this will be the height here. Let's say that this distance here is x, this horizontal distance is x. So we can use simple trig functions to find it. So we can say that the sine of pi over 3, opposite over hypotenuse, is h over 4. So from this we can see that h is 3.46. We can also write down the cosine of this angle, which is simply adjacent over hypotenuse, so x over 4. From this we can find x to be 2. And then again we use the same volume formula, so 1/2 times 10 plus x, so 12 plus 10 multiplied by the height, which was 3.46. And we again multiply by 3 to find this to be 114 meters squared.